Hello class, I'm Mr. Slusher. Welcome to lesson 10-4. I hope your quarantine's going well, staying home, staying healthy. Avoid large gatherings. You've heard it all. Okay, so today we're going to talk about section 10-4, which is logarithmic functions. Okay, you're going to get an introduction to that today, and then later on we're going to do a lot more with them, and you'll see that they're quite useful. Okay, so last section in 10.3 we did inverse functions as well as nested functions. But let's think about these inverse functions. For instance, 2 to the x. We know this function has an inverse because it passes the horizontal line test. Today we're going to talk about what that inverse is. This function 2 to the x. Its inverse is actually the log function. And we can see it is a mirror image across the line y equals x. And in fact, if you had a point on the graph of 2 to the x of, say, nk, that point would also be on this graph, but it would show up as, of course, kn. And so that's what the logarithm function is. It's the inverse of the exponential functions. Okay, so today we're going to look at some examples of that. Okay, suppose, basically what a log function is, suppose we have log base 6, 36 equals 2. So what that tells me is 36 equals 2. The way I say that in exponential form is 6 raised to what power? In this case, the power of 2 is equal to 36. Okay, so you're going to get very comfortable moving back and forth between logarithmic form and exponential form. Okay, this base here, this can change. We can go into any base we want except 1, because everything 1 to any power is still going to be 1, so that's kind of useless. So any power other than 1, we can have a base. So what about, let's look at another example. Suppose I have, let's go with log 2 equals 1. The way I say that is 2 raised to the power of 1 is equal to 2. Okay? Hopefully that's becoming clear. And there's some really good examples in your book if you have any problems with that. Let's take another look at another one here. How about log of 10, and I want 0, I don't want a negative. 0.001 is equal to -3. Okay, so how did we say this in exponential form? Of course, we have log base 10 of 0.001, or 1,000, is equal to -3. So how I would write that in exponential form is 10 raised to the -3 is equal to 0.001. So remember in one of the first sections of chapter 10, we saw that what a negative exponent does for us, that's equivalent to 1 over 10 cubed. Okay, so that's 1 over 10, add some zeros, and that gives me a 1 over 1,000, which is 1,000. Okay? So this is just a shortcut way of writing some things. And also, let me show you another thing that logarithms can do for us. Suppose we have an equation that we're trying to solve. It's something like this. 3 to the x equals 17. Okay, you may have seen problems similar to this in, say, 10-1 or 10-2, and we've solved them by finding a similar base and then equating the exponents. Well, in this case, you can see that I can't get a similar base out of these things, so there's really no way to solve this. But what I'm going to do is I'm going to solve it using exponents. So I can actually write this as log base 3, 17 is equal to x. Okay, and now I can find the log base 3 of 17 using some tricks which we're going to learn in the next couple of sections. We're going to change that base and things, but for now, suffice it to say, this is something that I can solve. So this is a powerful tool for solving exponential equations, which before we had no tool to do that. Okay, so let's just do some practice problems, and I'll put up some more examples. Work along with me, get comfortable using them, and then you'll should be able to complete your assignment quite easily. Okay, here we go. Number 2 in your written exercises in 10-4 says, I need to simplify log base 4, 16. Okay, to simplify that, I just get into the exponential mindset. What power do I raise 4 to in order to equal 16? So it's going to be 4 raised to what power is 16? And I know the answer, and that's 2. 4 squared is 16. So I can work that quite easily. That's a very simple one. Okay, let's look at another one here. Okay, here's number 6. Log base 8 is equal to 4. Okay, this one's a little more complicated, so I have to start thinking, okay, what power am I going to raise 8 to? Let's write it this way, in order to equal 4. Okay, if you remember from the last section or two, I can find a similar base here and work it that way. And it looks like I'm going to use 2 for my similar base. So I'm going to go 2 cubed power of x is equal to 2 squared. Okay, this was rule number 1 of the rule of exponents. Exponent raised to an exponent is the same as multiplying, so I can simplify this as 2 to the 3x is equal to 2 squared. Okay, so now I have, coming up here, equating the exponents, 3 to the x is equal to 2. So that gives me divide both sides by 3, and I know that x is equal to 2/3. Okay, get the idea? So the way we think about these is really the key. Log base 4, 16. What power do I raise 4 to in order to get 16? And of course the answer is 2. Okay, so there's the information that you need in order to solve these problems. Pair that with the previous knowledge that we've gained from the first few sections in this chapter about the laws of exponents, and you should have no problem completing the exercises for today. Thank you.